Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve and graph a compound inequality with the conjunction OR. Now, remember when we're solving and graphing for compound inequalities with AND, our inequality had to be true for, or our solution had to be true for both of the inequalities. All right? But when an OR, our solution is a part of our inequality if it's true for one of the inequalities or the other inequality. So we're going to make sure we represent, again, both of them on the same axis, and because our values can be true for one or the other, or both. So, which is not going to not come into play for one of these problems. But basically, what's nice at least about the OR compared to the AND, you know, a lot of times we rewrite them as one inequality, and sometimes we have to separate them, or it becomes a little difficult. ORs, we already have them separated. So basically, we're just going to treat them like two separate inequalities, but graph their solution on the same axis, because the compound inequalities, our solution is going to needs to represent both of the inequalities. So basically, I'm just going to apply my inverse operations here to solve. So I'll subtract 1 here on both sides. By doing that, I'm left with x is less than -4. Or, here I'll add a 2 to both sides. Or x is greater than +2. So now, to go ahead and graph this, I'm just going to create my coordinate axis here. And you're going to want to make sure that when you have two inequalities that your number line can at least hold, you set your scales so it's at least going to cover between -4 and 2. So I'm going to set 0 to be like right here. And I'm going to do 1, 2, 3, 4, -1, -2, -3, -4, -5, -6. OK. So now, basically, we're going to graph is we're just going to graph both of them separately, but on the same number line. So x is less than -4. So I'm going to make a nice big circle at -4. It's less than, so it's going to be an open circle. All the values that are less than -4 are going to go to your left. Make sure you also include the arrow, because it's going to continue going to the left. And then x is greater than 2. So I'm going to make a nice big circle. Again, that's open. The values that are greater than 2, though, are going to be going to the right. So therefore, the values that are going to make this inequality true are going to be the solutions that either make this inequality true or make that inequality true. OK? So 3 is a solution. -5 is a solution. However, 0 is not a solution because it does not fall in either of these graphs for the inequalities. So let's go ahead and do another one. This one is, again, just another simple little one step here. So to use my inverse operations, I'm going to add 4 to both sides. And I now have x is less than or equal to a -2, or subtract 2, subtract 2, x is greater than 3. OK, so now, again, we're just going to go ahead and graph. Now let's use the green. I got to use up a lot of those green markers. So let's see here. Let's have 0 be right here. Let's do 1, 2, 3, 4, 5, 6, -1, -2, -3, 4, -5. OK. So again, all we simply do is we find our two values. We put a nice big open circle at -2. And we put a nice big open circle at 3. Since that's less than or equal to, that's going to be solid. And less than or equal to is going to be going to the left. When it's x is greater than 3, that's going to be going to the right. And there we go. So you're basically just solving them separately and then graphing them separately, but on the same number line. Let's go over here. Now we have some two-step equations, so it's going to be a little bit more difficult. So in this case, we're just going, not really difficult, but a little bit, couple extra more steps. So we have 2 plus 3x. You can see my x is being multiplied by 3 and added by 2. So we always undo addition and subtraction first. So therefore, I obtain 3x is less than -15. Then I divide by 3, divide by 3. X is less than -5. Remember, I'm dividing by a positive number. I'm dividing by a positive number. Even though that -15 is negative, even though the 15 is negative, since I'm dividing by a positive number, I'm not going to have to flip the sign. So that's going to be or. Here, I'll subtract 4 first on both sides. And I'm left with 2x is greater than 3. Then I divide by 2 on both sides, and I get x is greater than, x is greater than 3/2. Now, I hate when I have fractions, especially when we're doing our number line with integers, but it's OK. Just determine what, either write the fraction as a mixed number, which would be 2 1/2, or rewrite it as a decimal, which would be 1.5. Then just choose the value in between those integers. I wouldn't really recommend making your your scale on your number line in fractions or in decimals, unless that's the way it is, or your teacher wants everything exact. OK, so my number line, though, has to include -5 up to like 1.5. So I'm going to have kind of like 0 be like right here. So 1, 2, 3. I'll do -1, -2, -3, -4, -5, -6, -7. OK, so again, just like we did before when I'm dropping all my markers, at least the caps. Now what we're simply going to do is put a point at -5, which would be a nice big open circle. That's x is less than -5, so that's going to be open. And it's going to be going to the left. Make sure you include your arrows. X is greater than 3/2, which again, as I mentioned, is like 1.5. So that's going to be like right there. And that's greater than, so it's going to be open. You're going to your right. And that's what your graph will look like. All right, on to our final example. So here, we notice we have some negative x's. So we'll remember, whenever we have, we're probably going to have to apply some operations of flipping the sign. But again, let's get to our inverse operations first. So I add 4 to both sides. I'm left with now -x is greater than or equal to 5. Then you see, I need to solve for positive x. So therefore, I need to divide by a -1. And I am going to put my divide by -1 on both sides. I am going to put my sign here in blue so that I can remind myself that I have now flipped the sign. Because I make the mistake just like you guys do all the time. I forget to flip the sign. I say, and I know it, I just forget to do it. Here, we're going to do the same inverse operations. Always undo addition and subtraction first. Therefore, I have -5x is less than or equal to -10. Then, again, I'm going to divide by a -5. So since I'm dividing by a negative number, I'm going to have to flip the sign. So this becomes x is greater than or equal to +2. OK, so now we can go ahead and get into our graph, just like we've done with the other problems here. So I'm going to create a nice little number line. Now my number line has to go from -5 to 2. So I'm going to put like 0 here. 1, 2, 3, 4. -1, -2, -3, -4, -5, -6. Kind of a wider scale, but that's OK. Again, you make your point here at -5. That's less than or equal to, so it's going to be a closed. And that's going to be going to your left. Over at 2, that's going to be greater than or equal to, so that's going to be a closed circle, and that's going to go to the right. So there you go, ladies and gentlemen. That is how you solve and graph compound inequalities with the conjunction OR. Thanks. Just making sure my graphs, I did my closed dots perfect. Good.